So the reason why we have a couple of different ways to graph algebraically, or not graph algebraically, solve systems algebraically, is because graphing sometimes has a very, it's not very accurate. We end up with points that don't fall on exact intersections. We may end up with graphs that need to be far too large than we're able to draw. So a couple of different reasons. So we've already looked at elimination as one algebraic method. Another algebraic method to solve linear systems is by something we call elimination, which is just basically adding or subtracting the two equations together in order to solve for a single variable, or in order to get a single variable equation. And we can take that single variable equation and solve for that variable, and then resubstitute what we find back into in one of the other equations to find the other missing variable. Okay, so remember just a couple of things. Properties of linear systems. You do not change the solution when you multiply both sides of either equation by a constant. You add or subtract, and then with elimination you add or subtract the equations together. So what that means is that if I have an equation x plus y is equal to 3, big pen, x plus y is equal to 3, then if I decide to increase everything by a factor of 3, multiply all of this by 3, I end up getting 3x plus 3y is equal to 9. I have not changed the equation at all. I've just increased everything by a factor of 3. And it's this process that we have to go through sometimes with elimination in order to get equations to look similar, or at least get one of the variables to look very similar, so that we can add or subtract the two together. Okay? And then what we do is, if we have, if this is our system, x plus 2y is equal to 7, and x plus 5y is equal to 2, then if I subtract, actually, you know what, I'm going to change this to a negative x, just for simplicity. If I add these two equations together, so if I take this equation and I add it to this equation, then we'll see that the plus x here and the minus x here cancel, which will leave us with 7y is equal to 9, and which is an equation with a single variable. We can solve, divide by 7, divide by 7. I get y is equal to 9 over 7. And then I can take this value, put it back into one of these equations to find x. So that's basically the process we're going through. Now you can do either addition or subtraction to cancel out one of those variables, and that's what all of these steps down here tell us. Okay, so I'll let you read through those steps. I want to get to an example. So example 1a. Solve algebraically using elimination. So I have 5x plus 4y is equal to 40, and 5x plus 6y is equal to 50. You will notice already that these variable terms are exactly the same. Okay? So if I subtract those from each other, I'm going to end up with 0. Those are going to cancel out. So essentially that's what I decide to do. I'm going to subtract that equation from the equation above. Okay? Now this is a tricky step when you're doing subtraction. You have to remember that and remember our old days subtraction, 237 take away 12. This is 237 take away this whole entire 12, okay? Not just the 1 or not just the 2. So when we have multiple terms, we have to remember to take away each of those terms. Okay? So what I like to do when I'm doing subtraction is to put a bracket around all of the second equation so that I remember that's what I'm subtracting. And I simply go, well, I say simply, 5x minus, or subtract 5x is equal to 0x. And then I go 4y minus 6y. 4 minus 6 is a minus 2y equals 40. I messed up my line there. 40 minus 50. 40 minus 50, negative 10. Okay? And then you'll see that we have an equation. This is 0. So we have an equation now that is just minus 2y is equal to negative 10. And I can solve that. Divide by negative 2. Divide by negative 2. Y is equal to negative 5. So now I have a value for y. I'm going to take that value for y and I'm going to substitute it back into either one of these two equations. It doesn't matter which one, pick one. I generally try and pick the easier or simpler one to work with, but in this case they both look very similar. So I'll take the top one. I go 5, no, sorry, what is it? 5x plus 4y. 5x plus 4y is equal to 40. And I put this minus 5 in for y. 5x plus 4 times minus 5 is equal to 40. 5x minus 20 is equal to 40. Add 20, add 20. I get 5x is equal to 60. Divide by 5, divide by 5. X is equal to 12. Took me a while to figure that out. So now I have a solution to my system. Now, after the algebra that we've done, my solution to my system is 12, negative 5. And then, of course, you would have to go through all the verification steps. Okay? Did I mess that up? I messed that up so bad I got to start again. Something's wrong. Haha, there we go. Nasty negatives. This is incorrect because a negative divided by a negative should be a positive. So this is just 5. So if I go down here and I change this to a positive 5, this becomes a positive 20. I then have to subtract 20. I need to subtract 20. I hope you caught that. Divide by, so this is not going to be 60. This is going to be 20. I still divide by 5. And this time I get 4. So this is 4. I'll have to redo that video at some point to make sure that I have it correct. But you know what would have made sure in my own mind that that I did know that I did something wrong? Well, first of all, I was looking at my other piece of paper and I realized I'd done something wrong. But what I would have done is I would have taken my original values of 12 and minus 5 and I would have verified, substituted them back into both equations to see the hold true, and it wouldn't have held true. Something would have went wrong, and then I would have gone all the way back here and checked to see where I went wrong and eventually found it. Okay, so you know what? Those nasty negatives, they get everybody, and they get everybody all the time, forever. So just be careful, and when you have the opportunity to verify and the time and space to do so, then I would suggest doing that.